Okay. 4-6. Similar triangles. Hey, we went over congruent polygons, so I'm going to move this a little bit.
Oh, you're good. I'm sorry.
We went over. Mr. Carlson.
Oh.
Okay, we went over congruent polygons before. That's what we were just talking about, actually. So we said congruent polygons, they have the same side lengths and angle measures. Congruent polygons have the same side lengths and angle measures. But we already knew that, right? We knew that all the corresponding sides have the same length and all the corresponding angles have the same length. Not that every side is the same length, because we have like 3, 4, and 5, but that 3 corresponds to 3, 4 to 4, 5 to 5, and they're congruent. Just like your angles are not necessarily all the same measure, but they correspond to congruent angles. So these two are congruent at the top, on the bottom left, these are congruent, on the bottom right, these are congruent. Those were our congruent triangles, or congruent polygons in general. Now we'll have this thing called similar polygons, where they're not necessarily congruent. We'll have this little symbol. So we like steal the tilde from the congruent polygons, from the congruent symbol, and we just use that. So we don't have the equal sign here, we just have that little tilde there. So go ahead and draw that tilde in if you haven't already. Now, two polygons that are similar will have the same angle measures. So just like congruent polygons, they'll have the same angle measures. But the difference is that these can have different side lengths. I know it's a lot to fit in there, and it actually doesn't fit in there, and I'm sorry for that.
It's okay.
And thanks. So they can be different side lengths though. So in this figure, we have triangle ABC similar to triangle DEF. So just like we can have the congruent symbol, we can have the similar symbol and just read similar. The triangles are similar. Now, for similar polygons, we said the corresponding angles are congruent. And we have that the ratio, spelled RATIO, ratio of corresponding sides are equal. So we still have corresponding sides, but instead of them being congruent, we have the ratios being equal. Their ratios will be the same. We'll kind of talk about that here in a second. Does anybody know what a ratio is? Anybody raise their hand and tell me what a ratio might be? Lily, what do you think?
Isn't it like, so if you're 0 from 10, it's somewhere between there?
Not necessarily. It could be in some terms, but that wouldn't be a definition of it. It could be at times.
Okay.
Sophia, what do you think?
One thing compared to another, like, this side is 2, and then it would be like, there's 2 to 5.
Okay, so we use it as the comparison between two things. Okay, we use it as a comparison between two things. If two things are in a ratio, we'll say that for every one of this, we might have 2 of these.
Yeah.
So if we have for every like 1 cup of flour, we'll have 2 cups of sugar. If we have 2 cups of flour, how many cups of sugar do we have? 4, right? You double the top number, you double the bottom number. If we have 3 cups of flour, how many cups of sugar do we have? 6. So we triple the top, we triple the bottom. So it's like a fraction, but there's some more meaning there.
Where is your mother?
So when we do the ratio, just like in that example, we had a certain thing on the top and a certain thing on the bottom the whole time. We had the flour on the top and we had the sugar on the bottom. For these, we'll put our small triangle on the top and we'll put our big triangle on the bottom. Because if we look at these two triangles, it's obviously that one is smaller and one is bigger, correct? Triangle ABC is the bigger or smaller triangle? Smaller. It's obviously the smaller one, right? And DEF would be the bigger one. So it's just to kind of separate it off. So the bracket's just to kind of separate, hey, this is separate from what we're doing. It could be the same as like a little squiggly line here to say, hey, we're just gonna kind of divide it off? That's a good question. It's not actually part of it. It's not necessary in there. It's just a little divider. Okay. I'm gonna have you hold that thought. Okay. So if we have the side AB with a length of 3, what side does that correspond to for our big triangle? DE with a length of 6. And we'll say that the ratio of these two corresponding sides will be equal to the ratios of the other pairs of corresponding sides as well. So who can give me another ratio for corresponding sides? Small triangle over the big triangle. Faith.
CB, which is 5, and then FB, which is 10.
Okay, so CB over FE, which is 5 over 10. And then we have one more pair. Who can give that to me? Sophia?
CB over.
We just
No.
did CB.
Yeah, okay, I know that. I was like, messing that up. Okay. CA over FD.
Okay, CA, which is 4, over FD, which is 8. Now we're saying that the ratio of these corresponding sides is equal if the triangles are similar. So it's like in congruent triangles, we have the same side lengths. Now here we'll have the same ratio of side lengths. So what's 3 divided by 6 simplified to?
2.
3 divided by 6 is
1/2.
1 over 2. 6 divided by 3 would be 2. Here's it's the other way. 5 divided by 10 is, and 4 divided by 8 is. So all of these are equal to 1/2. So the ratio of the corresponding sides are all 1/2. So if the ratios are all the same, the ratios are equal. So did that kind of answer the question you had earlier?
Oh no, I was had a question about I thought polygons were the octagon too.
It could be. This is a polygon too. Polygon is just means a many-sided figure. Okay. Questions on this? Max, I'll have you catch up in a bit, okay? You might need to copy someone else's later to catch up, okay? Or watch the first part of the video. Okay. So for the figure above, right above this, because this is right below where we're at, okay, right above this halfway part, we can write a similarity statement and a statement of proportionality. So just like we had a congruent statement, where we had a triangle is congruent to a triangle, we had a similarity statement. So it was already there, and we list the corresponding angles in the right order. So it already said triangle ABC was congruent to triangle DEF, correct? Similar. Thank you very much. They're similar to triangle DEF. And note, we still put the corresponding angles in the same order. Just like we did with our congruent triangles, we had to have those corresponding angles matched up.
Wait, what is this?
That means similar. Now we can also have a statement of proportionality. So we said that the side AB, that bottom side of that first triangle, the little triangle, matched up with the bottom side of the big triangle, DE. So we said that this side over this side was equal to CB over FE, or sorry, CB over EF, or FE, yeah, that would work as well. And that was equal to AC over DF. So we said that those ratios were equal. Now we put the numbers above here, what we call a statement of proportionality. Now what that means is a statement of proportionality. Proportion is the word we're trying to look at here. Proportion, proportion. It's like you're supporting portions. So if you, proportion is two ratios that are equal. So we're saying the ratio of these two corresponding sides, small triangle, big triangle, is equal to the ratio of these two sides, small to big. We knew they were both 1/2. So a proportion is just saying these are two ratios that are equal. In this case, we had not 2, but we have 3 ratios that are equal, what we call a statement of proportionality. Patty, put it away. Thank you. Okay. So in this example now, we're kind of moving on to a different example here. Let's list our corresponding sides.
AB.
Side AB corresponds with what? Side AB corresponds with
DE.
DE. 1 arc to 3 arcs for the angles, 1 arc to 3 arcs for the angles. It would give me another two sides that correspond. Nick.
CD and FE.
Okay, side CB and side FE. Very good. And then who can give me the last pair of corresponding sides here? Gracie. AC and DF. Very good. Those would be corresponding sides as well.
How do you get out the inside?
I mean, you can do whatever somebody wants, but I just go like here, come back up, loop. That's how I do mine.
Okay.
Hey, also, by the way, number 1, we're skipping that number 1 now. They're kind of hidden below the triangles, by the way. Okay. So, what's the ratio of the corresponding sides? So we wanted the small triangle.
Oh, I got it. Thanks, Mr. Carlson.
You're welcome.
What is it then?
Okay, so I heard someone say 12 over 36. That would be one of them. Putting the small triangle over the big triangle. AC over DF. Okay, 5 over 15. We have one more. 10 over 30, okay? So if these two triangles are similar, then we need all these ratios to be equal. What's 12 over 36 simplified to? 1/3. 1 over 3. What's 5 over 15 simplified to? 1 over 3. 1/3. What's 10 over 30 simplified to? 1/3. So they do all equal to 1/3. So the ratios are the same, meaning the triangles are going to be similar. Ratios are the same, corresponding angles are congruent. Now this 1/3 that we got, the simplified ratio, we call this our scale factor. Have you ever heard of things being scaled, or maybe like pictures are not to scale or something like that? Okay, or a scale model. Okay, a scale model is something that would be like the Empire State Building. Obviously a very large building, correct? The Empire State Building in New York, okay? If you made it like this tall so it fits on a desk, but you made everything to scale. You're saying that the windows are the same size relative to the building itself as it would be normally. So if like the buildings were like 2 feet before, they might only be like an inch now. But the height of the building and everything like that got shrunk down by the same amount. They all got shrunk down by the same amount, and so it's shrunk by a scale factor, as we call it. Factor like being multiplied. So we're saying that we took this big triangle here, triangle DEF, multiplied every side by 1/3, and we got our small triangle. We went from our big triangle, multiplied everything by 1/3, and hey, now we have our small triangle. That's called a scale factor. We scaled it, decreased it proportionally by that factor, 1/3. How would we go from the small triangle to the big triangle?
Increase it by 3,
Multiply it by a scale factor of 3. Because if we went big over small, we would have 3 instead of 1/3. Because we know these angles are, corresponding angles are congruent, and the corresponding sides, the ratio of the corresponding sides are equal, we can say that triangle ABC is similar to triangle DEF. Hey, what's the idea of perimeter here? What's perimeter mean? All the sides added together because it's the distance around the figure. So if you add up all the sides, here, let's do the one for the small triangle. 5 plus 12 plus 10. Add all the sides together. Is this the distance around it? 27. The big triangle. We'll have 15 plus 36 plus 30. This ends up being 81. What's the ratio of the perimeter? Small to big, 27 over 81. Does any number go into both of these?
Yes.
What?
9.
9 goes into 27 how many times?
3 and 9.
And 9, okay? And then does this get any smaller?
Yes. 1/3.
What do we notice about the ratio of the perimeters compared to the ratio of our scale factors? They're the same.
It was meant to be.
It was.
So you only need to do one.
The ratio of the perimeters will always be the same as the scale factor was.
So can you just do the, can you just pick one? You
Yeah, you could just, you could pick one you wanted, then figure out the other one. Yeah. So if we're asked to do perimeters, we could do that way. That's something we'll learn about more later as well. Yes, Nick.
I just realized this, that you can actually divide, instead of divide by 9, you can divide by 27.
So because we divided by 9 and 3, you can multiply them together and say, hey, we can divide by 27. Get there faster. Yeah, but we might not always know, hey, 81 is divisible by 27. You know, so we can get there in multiple steps if we need. But if you see it, awesome. Sophia.
So, would you allow us to multiply it on a test instead of dividing to get to the scale?
What would you multiply?
Like the big over the small.
I don't understand how you would multiply to get there.
I don't know, but you said that you could go like the big over the small triangle.
Oh, so if we did big over small here, we'd get 3. That's how we get from the small to the big. But we aren't actually traveling from the small to the big or the big to the small. We're just saying that's how the scale factor works. Does that make more sense?
Yes, it does.
Okay, good question. Other questions on this first page?
No, sir.
Okay, we're going to start using some properties of this.
Great.
But first,
Yay.
let's look at these figures. Do we think these two figures are congruent to each other?
Yes.
Okay, so we're thinking yes. Let's look at it though, okay? So the angles, they are in fact congruent, right? Corresponding angles are congruent. Okay? Now, we need to figure out if the congruent figures are also similar to each other. We need to figure out if congruent figures are also similar to each other. So I got off, that was the question we're asking. We need to figure out if they're also similar. We have these two criteria that the angles are congruent, which they are. And we also need the ratio of corresponding sides to be equal.
So they're not.
Okay? So we need the ratio of corresponding sides to be equal. So this side in the left triangle, this time we're going to have to put left over right because we don't have it necessarily big and small.
Left triangle.
4 corresponds with what? 4. 5 corresponds with,
5,
and 3 corresponds with.
3,
What is 4 over 4?
1,
1 over 1, or just 1. What's 5 over 5?
1,
1, and what's 3 over 3? 1. Are the ratio of the sides all the same?
Yes.
Yeah, so they are in fact similar. So congruent figures are also similar, but their scale factor is just 1. Instead of having a scale factor of like 1/3 like we had last time, they have a scale factor of 1. I like your socks.
like myself.
Thanks, dog.
Actually, my shoes are pretty spiky.
Your socks I guess are okay. But yeah, those checker pants are nice. Okay? Let's look right below this now. Determine whether these two polygons are similar, and if they are, write a similarity statement and find the scale factor. Okay? So, what do we need for two triangles to be similar? The ratio of corresponding sides has to be the same. So let's go with big to small, or small over big again. Okay, 5 over, okay. What else? Okay, so hey, let's get
You're forgetting a triangle. Small triangle, big.
let's get some calculators real quick.
Big calculators
Okay.
or small?
So I just picked this batch of calculators this morning actually, so they're fresh. Okay, I went out after a long weekend and just picked a bunch of fresh calculators.
No, you didn't. How thoughtful.
I mean, I did.
No.
I just picked them for my garden, you know.
I mean, they're right.
Hoping it spoils it.
Ooh,
The
God,
harvest is plentiful.
Did you hear what Max said?
What?
Max said again.
Are they right?
They are perfectly right. They're at the great stage.
Mine's over to. I mean. That's embarrassing.
Yeah, I'm all out of my mobile. Here you go. You get this one.
They
Okay.
over.
Look at the top of the line.
Hey.
Mine's under right.
So let's figure out what these ratios are.
We got divided.
we could figure out like 15 over 5 or 5 over 15. We can say that was 1/3. 5 over 6, that doesn't simplify. What is 5 over 6 if you put it in a calculator? 5 divided by 6 equals 0.83 repeating.
Yeah.
Okay, what's 5 over 6? 5 over 6?
Oh,
Oh, that's the same thing. Okay,
I thought you said 3 over 4.
gotcha. What's 3 over 4?
0.75.
Are the ratio of these sides equal?
No.
Yeah.
Are they similar then?
No.
Not similar.
And this would be enough of an explanation because we know that the ratios are equal. If you show me that, you write not similar, I know exactly what you did and I agree with you.
Me too.
Could we also look at the angles? Because, hey, corresponding angles need to be congruent. Is this angle B congruent to angle E?
No.
Is angle C congruent to angle F?
No.
No. So could we have known anyway
Yeah.
that this was similar? Yeah, we could have. Okay. What was that? Review time. Okay. Not quite. So let's look right below this. Let's look at this right one first. Let's look at the one on the right first. We're supposed to find the missing side lengths in each problem if the triangles are similar. So we're told the triangles are similar. We're told that. Right now, these two triangles in B, we're starting here, B, do not cross A out, but let's start with B. We're told they're similar. And the matching dots mean that the angles are congruent. So these angles are congruent. So our corresponding angles congruent to these triangles? Yeah, they should be. Okay, that's good. So these triangles are similar. So we can say from small to big, small triangle to big triangle, 5 over what
15.
is equal to,
1/3.
oh, it does equal 1/3, but what's our other next statement?
4 over D.
4 over D, and we're trying to find the length of D. Now, what do we do when we have two fractions equal to each other? Does anybody remember how we solve these? Very good, we cross multiply. That means we multiply 5 times D, and they're both in the numerator now. So what's 5 times D? And what's 15 times 4?
60.
6D, and that's in the top, that's in the numerator on the right side. Yes, Marley?
If you make the D.
That would be okay, but I would say probably a good idea to try and keep it how it is. As given in general.
Divide by 5.
Now we would divide by 5. Very good, Nathan. And D is equal to 12. So our missing side length is 12 meters.
12 meters.
Okay. Yes, Faith?
I did it where I did 5 over 15, that's 1/3, and then I multiplied 4 by 3.
We'll get there. Okay. So that was something I wanted us to see as well after this. So first, we can cross multiply. But hey, Faith said what she did, but she had 5 over 15 is equal to 4 over D. She said 5 over 15 simplified to 1 over 3. So now we cross multiply with this. What's 1 times D? Just D. And what's 3 times 4? Is D equal to 12?
Yes.
No, I was just trying to get it until I added the D.
Okay. So what someone was saying, hey, they recognized that we multiplied. Guys, cut it out. They recognized that we multiplied 5 times 3 to get 15, so 4 has to be multiplied by the same thing to get to D. So you can do that as well. There's a couple different ways we can do these. Cross multiplying will always work if we can't figure other things out. And then simplifying can make our work a little bit easier as well, so we don't get as big of numbers. We simplify. But hey, you guys will have a calculator, right? You guys punch numbers into calculators and push enter?
That's the only way I do stuff.
Okay. Let's look at A now. If you look at A, we have two triangles here. We have this triangle in the top here. That's kind of like part of the triangle. And then we have the whole thing is its own triangle as well. Okay? Abby, what are you thinking? Okay, so let's say, what's the length of this small triangle, this side? 24. Hey, what's funnier than 24?
25.
26,
Okay.
27, 28, 29.
What's the length of this whole side?
30.
30. How'd you get? That's bad there. How'd you get 30, Gracie?
Because I'm smart. 24 plus 6.
24 plus 6. The whole side is 30. Voice is off.
You forgot big and small.
Okay. Does that help you out, Nathan?
Thank you.
Okay.
I'm confused.
Okay. So then on the second side, small triangle 28 compares to what? Does 24 over 30 simplify?
I don't know.
Yeah.
So what?
I don't know, but divide by 2 on each side.
6.
We can divide by 6. What's 24 divided by 6?
15.
12 over
24 divided by
12 over 4.
We can do that too. We can get even smaller. 24 divided by 6 is 30 divided by 6 is 4 over 5. So now we can cross multiply.
I got a question.
Mr. Gossel, why did it say?
Why are you doing it so complicated?
Because this is the actual math we do there. Okay? Who said they had a question?
Me.
Okay.
Bro, my
Yeah.
hands are raised.
Okay. Yes, Randall. Sorry. What's your question?
I don't understand why we added 24 and 6.
Okay? Because we have to get
Why did
the.
it just be one angle then?
We want the whole side.
Yeah, so when we add it as just one.
24 and 6 add together to be 30.
Yeah, but I don't know why we did the 24.
Okay, so over here, we did the small triangle over the big triangle, correct? So we did like 5
Yeah,
over
but
15.
that's different.
Okay, but here, we have the small triangle has a side of 24. The big triangle has a side of 30. So 24 over 30. Just like we had 5 over 15. Because if we were to separate these, Randall, and we said this is 24 and this is 30, it would be the same thing.
It'd be 6 though. I don't understand it.
No, this length is 30. Is this whole thing 6, Randall? From here to here, is that 6?
Alright, I can see it.
That makes more sense.
Yeah, this doesn't make sense. I
Well,
got it. It's just,
I still.
I don't
Okay.
like it.
Gracie, what's your question?
For the 24 with 30, can't you like divide them by 2?
You could make it 12 over 15.
Okay.
And does 12 over 15 simplify more as well?
No. Yes. Wait.
So we could get here either way, or you could just reduce it that and it would still help you. You would just have more to divide by here, but we're using a calculator, so it's still not as difficult for us, thankfully. Okay? Sophie, what's your question?
So, since we're cross multiplying,
Yep.
would we multiply 28 by 5?
Yes. What's 28 times 5? Put it in your calculator.
145.
Oh,
I disagree.
My bed's not bad.
No? Stop guessing.
140.
140.
I did that wrong. My bad.
Yeah.
Sorry, still.
I already know how you found it.
I'm just so much faster.
Divide both sides by 4. X is equal to.
35.
Thank you.
Does that say 140?
Yes.
Okay, hold on. How do you get 4x equals
Okay.
Take
We cross multiply. Cross multiply means that you multiply the left side, the left numerator times the right denominator. So left top times the right bottom. 4 times x is
4x.
4x. 5 times 28,
140.
140. Okay, so we had 24 over 30, and we said that simplified down to 4 over 5. Okay? You didn't get 35? Yeah, you got the wrong answer.
But it makes sense.
No, because this whole side's 30. You just made that 6.
Yeah, we took.
But the whole side has to be 30. You have to go 24 to
That's what I'm
30.
saying.
Not
That
24.
makes no sense. It says 6.
Isn't it a triangle?
It says 6, but Randall, that's just this part
Okay,
here.
yeah, but they're two separate triangles.
But this is, Randall, is this right here though? Is that a triangle?
No.
No. The whole thing is, and the whole thing is 24 plus 6, 30. Probably a good idea.
Get the dad like Wiz Khalifa.
Wait, what?
Not like Wiz Khalifa.
My dad push
No, no,
up.
no.
Who is with?
Dad pushed him off today.
Why?
Because I did chest today.
Dude,
So,
18
my chest
Is
muscles are
that
tired.
chest is sore? I benched 25 today.
Hey, nice.
Oh.
I'll get there one day.
What?
I'll get there one day.
You can do more than that.
What?
You can do more than that. What's your
No,
max?
definitely not.
What's your max?
I don't know what it is right now,
I say.
but my PR was 275. 275 pounds. It's 2 plates that are 25 on each side.
Christian did that. Christian did that first year.
Okay? Hey, voices off. Let's try another one real quick, okay? Let's try another one. Let's do letter C. Okay, let's do letter C. Hey, that's a good idea. Let's do letter C by ourselves. Let's do an independent practice. I think that's a good idea. Once again, matching dots means they are congruent angles. So work on C by yourself.
I'm trying to do C, don't distract me.
1 second, Max. I see you. Let's do it mathematically first. We can do it that way. I don't see any of your math. That's because you're 1 second.
Wait, Mr. Puzzle, I think a dumb question, but if the 3 is on top and the 1's on bottom, do we divide the 1 into 3 or 3 and now we're
Okay, what was your question?
But then this one's,
What's 15 times?
this still goes to my question too. If you did 5,
It's 5 divided by. But what is those across multiple, right?
A equals 9. You get it? Get it?
You said it was 1.
That's a clash.
I don't know what you said. I don't know.
For real, it's annoying.
Okay, and we're going to talk about this one up here. Thank you. Okay, somebody give me our proportion we set up.
5 over 15.
I'll do it.
5 over 15 equals what, Kennedy?
Can I tell you something?
3 over A. Very good. 5 over 15 would equal 3 over A. What, Gracie?
You don't have to do all the work.
I- 5, 10, 15. I know what you're talking about, but when we get to more complex ones, you might have to do this, okay? Nathan, what are you
So you
thinking?
put the small and the big on. You said once it gets more complicated, you got to do it. So
Maybe not on that part, but if you really need it, I can do it for you, okay?
thank you.
Hey, does 5 over 15 simplify?
Yeah.
To what?
3.
No.
1 over 3.
Thank you.
Different. No, it's not the same. Guys, I don't even know how to do this.
How do we, what do we do now?
Now we cross multiply.
Cross multiply. What is 1 times A?
Hey.
3 times 3.
9.
A is equal to,
9.
if we didn't simplify early,
You'll get 45.
you'll get,
45 equals 5.
very good, 45 is equal to 5A. You divide by 5, and A is still equal to 9. Same answer. Question on this one.
Dude, I is killing me. Gracie, come on to nurse, right?
You guys here's the thing. You know, if you wake up and you do that, you get like, but if you do that, you get
It just,
you don't get
it
eight.
just feels really dry.
That's again.
Yeah,
Yeah, it's worth it to you, I suppose.
yeah, I sometimes go overboard.
Because I don't know, I can always make partial points if I don't know what to do.
Did you wake up with like questions? So could we write down like 5 more
But
minutes?
I've had it all
I make
weekend.
that some 3, 6, 3, 3. Like a lot of
Yeah, I would get your stuff.
I've had it all weekend though, so it should be like.
Any sort of
Yeah,
work
I
getting
can
you working.
Big package, Gracie. Whoa,
Hey.
that's too far, Gracie.
Hey class, you might want to listen up because I have some instructions.
Yes, sir. We're
Okay. There's going to be more than 8 that we don't do, but before we get to the don't do's, I have another instruction. Everyone look at number 4. Number 4, what's that say? Change it to equiangular. On 4, change it to equiangular.
Me too, right?
It's up here now.
Thank you.
Oh, good lord.
Yeah, don't you worry. I wasn't expecting you guys to all remember how to spell that.
I can't say.
It's easy.
Good for you.
Shouldn't be.
Okay?
I
Okay. Go with me to the 3rd page now, please. To the 3rd page now.
So 28?
It starts at 28.
Thank you.
3rd page starts at 28, goes to 39. If you look at the instructions, right below 28, right before 29, it says decide whether it's possible to prove triangles congruent. If possible, tell which congruent postulator theorem you would use. And explain your reasoning. That last part, explain your reasoning, cross it out. Cross out that last explain your reasoning. On right below 28, right above 29, 3rd page, cross out that explain your reasoning. Very last sentence, even on the page. Okay, go to the 4th page. Go to the 4th page. It says the following triangles are congruent. Tell which congruence, postulate, or theorem you would use and explain your reasoning. Cross that out and instead, the following triangles are congruent, leave that, and then cross out the second part of it. Then tell which congruence, postulate, or theorem you would use and explain your reasoning. Cross that whole second sentence out. Instead, what I want is, I want the congruent statement, triangle something, 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 triangle screwed to triangle.
Okay, I'm just going to do triangle thingy. That's all.
If that helps you remember it, but I'm calling it congruent statement.
Triangle.
And I want the theorem you used.
Theorem. Okay.
I want the congruent statement and I want the theorem.
So like SSA
Wait, what's
or
the-
something?
Yep.
Okay.
That's not one of them. That's like triangle this is congruent to triangle this.
Okay.
Okay? Okay. Go back to the front because now I have some don't do's.
Yeah.
7 through 9, 14, 17 through 19, 37 through 38.
Wait.
It's gonna be on the
They're on the board. 41, 48 through 54.
This homework's gonna be really short. Thank you, Mr. Crossman.
Yeah, no problem.
Stop singing Hillary Dog.
It's a throwback.
I know it.
That's a banger.
I love it.
Hey.
Is that 48 through 54?
Correct.
I will take 3 and that was my
If you guys forget, this will also be on Google Classroom, and the video is also on there if you need some extra help on 4-6. Hey, the videos are on there for all of these as well, and you guys can look back at your notes. When is this review due? Wednesday. Next class.
We also have a test.
We do. We also have a test on Wednesday.
Yes.
There you go. That's the spirit.
Kylie.